Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O Levels Physics 5054. The paper we have selected to solve today is October-November 2024, and the code of the paper is 41. This paper 4, the ATP paper, belongs from the Zone 1. This paper has been published by the Cambridge Assessment International Education, and I have downloaded this paper from their website, School Sport Hub. This paper has not been created by me. This paper has been created by Cambridge Assessment International Education, and this is their property. I am just using this paper to show the solution. The solution is written by me. The marking scheme, the paper I'm using is from the Cambridge Assessment International Education. So this is their property, not mine. So all the credit for the paper and the marking scheme goes to the CAIE. I am in this video going to present you the solution of this paper to the best of my knowledge, to the best of my skills, and to the best of my abilities. So let's start today's paper. So here we go. So the time allowed for this paper is 1 hour, and this is alternative to practical. We call it paper 4. So let's start this paper. So here we go. The question number 1 is showing up on your screen. A student measures the volume of 2 identical straws by different methods. Method number 1. The student takes 1 straw and cut it into 5 pieces and that are equal in length. Lines up the pieces of straws as shown in the figure 1.1. Ensures the pieces of straws are touching. Figure 1.1 is drawn actual size. This, whatever is the size here, is the size. So then he says, measure and record length X and the D to the nearest 0.1 centimeter. So we have to, this word measure means by your instrument, measure it. So with the help of the scale, we are going to measure it, and then we will record them here. So you can see here the X is this length and the D is this length. So with the help of the scale, I measure these lengths and record them in there. So we measured them. The length X is 4.1 and the length D is 2.7. So because you see the paper we are using is a photocopy, so that's why whenever we photocopy these papers, the length shrinks a little bit. That's why our answer will be a little bit less than the real answer. The real answer is 4.3 and 2.8, but due to our answers are 4.1 and 2.7, this is no problem. Just write down whatever the length D is with the help of the scale, measure this length with the help of the scale and note them here. Okay. Then we have, he says, use your values of the X in the A first part to calculate the length L of the straw before it was cut into pieces. Because you have cut that straw into 5 equal pieces, so whatever is the value of the X, just multiply it with the 5, you will get the actual length of that straw. Okay, so we will 4.1 multiply 5, that's 20.5. So the actual length of that straw before cutting it into 5 equal parts is 20.5 centimeter. Then we will have the next part. Let's check the answer. 21.5. Our answer is also 21. Our answer is 20.5 because this value, they said this will be 4.3 because of the photocopy. Our answers are a little less, little shorter. So use your value for the D in the A first part to calculate the diameter of the one straw. Give your answer to the nearest 0.01. You see, you have placed 5 straws side by side. So 1, 2, 3, 4, 5. So basically this capital D value is representing the 5 diameters. So whatever is the D value, just divide it with the 5, you will get the diameter of the one straw. So our reading was 2.7. So I will divide 2.7 with the 5. I get 0.54 centimeter. So my answer is 0.54 centimeter. Our answers are little less than the actual values. The reason is because when you photocopy the paper, the length shrink, the diagram shrinks a little bit. And due to that reason, our answers are a little shorter. Okay, then he says, explain how the student uses a ruler and two set squares to make sure that the measurement of the D is as accurate as possible. So what you will do on your table, you will place 5 straws side by side, touching with each other. And on both the sides of those straws, you will place set squares, and you will place a ruler on the table, and you will measure the distance between the set squares. I will show you the diagram also. He says use your answer. This is a 1-mark question. We have to write down the, okay. So what we are going to do is we will place the set square side by side, and on the sides of the set squares, on the straws, I mean, we will place the set squares like this, and we will place a ruler in front of them like this, and we will measure the distance between the point A and the point B. And this way you will be able to find out the distance between this point, and that will be equal to the capital D. Align the set squares with the ruler and straws as shown in the diagram. Subtract the A from the B. Whatever is the reading on the point A and whatever is the reading on the B, from B subtract the A, you will get the capital D value. So let's check from the marking scheme. Use of set squares at each end lined up with the rule 1. Okay, so our answer is right. Okay, so this is what I am saying. Then we have the volume V1 of the straw is given by the equation. V1 is equal to 3.14 D square into L divided by the 4. Use your answers from the A second part and A third part to calculate the V1. Give your answer to 2 significant figures. It's a very simple question. You have to put the value of the small d here and value of the small l here, and just do the calculation and write the answers here. So let me show you. I have done this on the paper. So here we go. So V1 is equal to 3.14 D square into L divided by 4. So 3.14 into 0.54 square multiply 20.5 divided by 4. So you get 4.692. So if you use the original values which are given in the marking scheme, so this is my answer because our readings of length and the diameter are a little less. So if you go with the original readings, you will get 3.14 into 0.56 whole square into 21.5 divided by 4. So you will get 5.292, or which is approximately 5.3. So if we use the values which are given in the marking scheme, then we get this answer. So our answers are, so 5.3 correct to significant figure. You see, if we are doing this paper in your school, then you will be using these values, whatever is the value coming by the measurement. But when you will be appearing in the Cambridge exam, the paper will be original. So then the values will be automatically these values. Okay. So you don't have to worry. Even if you are getting this answer, there's no problem. But in a real Cambridge exam, you will obviously get these values. You see, when we photocopy a paper, the length, whatever the diagrams we have, their length shrinks a little bit. So that's why our readings are a little less. So let's go to the next question and next part of this question. He says, okay, then we are going to the next part. He says method number 2. The student takes the second straw, immerse the straw fully in a container of water as shown in the figure 1.2. Move the straw backwards and forwards in the water several times so that the water enters the straw. Puts a finger firmly over one end of the straw and removes the straw from the water. Put the straw above the open end of 50 centimeter cube measuring cylinder and then removes the finger so that the water is transferred into the measuring cylinder. The student repeats the process 4 more times for a total of 5 transfers. Okay, so figure 1.3 shows the total volume of water VT in the measuring cylinder. So what they have done, they fill the straw with the water and they are pouring that water in the straw into a measuring cylinder. They did this 5 times. And then they measure the water which is collected in that measuring cylinder. That reading is here. Write down the reading VT. Okay, so that reading is 21, 22, 23, 24. So that reading is something like 24. That reading is something like 24 centimeter cube. That reading is 24 centimeter cube. And then their question is calculate the average volume of the water V2 in one straw. So this volume is basically is representing 5 straws because you have done this 5 times. So you will divide that reading with the 5. So you will get the volume of the one straw. So the volume of the one straw will be 24 centimeter cube divided by 5. So that will be 4.8 centimeter cube. 4.8 centimeter cube. So 4.8 centimeter cube is the answer, sir. So I hope you understand this. Then their question is suggest 2 reasons why the V1 and V2 are different. So suggest V1 and V2 are different. V1 is, the volume in the first method we got, and V2 is the volume by measuring cylinder, which we got by using water. So the V1, in the V1, we are able to measure the diameter and the length of the straw, correct, up to 1 millimeter. And in the second method, and when we measure the volume, we are only able to measure it correctly up to 1 centimeter cube. And whenever we are using water, we are filling the straw with the water, it's possible that because the water is a wetting liquid, it sticks, it remains with the walls of the container. So when you are transferring water, this is possible that some of the water still remains in the straw. This is also possible that when you are transferring the water, the straw is not fully, is not filled up to its full capacity. It is also possible when you are pouring the water that some of the water has splashed out. So these can be different reasons. So let's see what we have here. Air bubbles may remain in the straw and some water remained in the straw, or in V1, external diameter is measured, in V2, internal volume is measured. Yes, this is very important. The last point is also we have written here. This solution is written by one of my students under my supervision. So you see, the dimensions which we have measured in the method number 1, they were external dimensions. We have measured the diameter from the outside. We have measured the length from the outside. But in the method number 2, we are measuring the internal volume. So that's why their readings are different, okay? So there can be many reasons for this. Let's check the marking scheme. Air bubbles in the straw in the method number 2. Internal volume is smaller than the external volume. That is also true. Straw becomes squashed or damaged during the process. That's possible. Small amount of water may remain in the straw. Water sticks to the fingers. Oh yeah. Some water falls out during transfer in the method number 2. Straws not completely filled. So you have to write just 2 reasons out of these reasons. So this is question number 1 of this paper. I hope you have understood. Okay, so we are going to the next question, which is the question number 2. He says, a student investigates series and parallel combinations of resistors. The student is provided with two resistors, X and Y, connected in the circuit shown in the figure 2.1. The resistors are not identical. The electromotive force EMF of the power supply is 3 volt. So here we have two resistors which are connected in series with each other. Here we have an ammeter. Parallel to the X resistor, we have connected a voltmeter. Here we have a battery which is 3 volt. We have also a switch here. This is the switch. So let's say what they say. The student closes the switch. Figure 2.2 shows the reading Vx on the voltmeter and Is on the ammeter. Record the reading Vx and Is. So this reading here on the Vs. So this is showing you the voltage drop across the X, and this reading is, so you see here from 0 to 1, they have made 5 portions. So this is 0 0.2, 0 0.4, 0 0.6, this is 0 0.8. So this is approximately 0 0.7. Okay. So this is the ammeter. So the reading is 0 0.7 volt. And this is showing the reading on the ammeter. So this is 0. So this is 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5. So this reading is between 0 0.2 and 0 0.3. So this reading is 0 0.25 ampere. So this reading is 0 0.2 ampere. So we have to note it down here. So we have to note it down here. So it's a 2 marks question, very simple, straightforward. So let's go to the, I have written this. So you can see here, I have written this 0 0.7. And this is 0 0.7 and this 0 0.25, 0 0.7 volt and 0 0.25 ampere. So let's check from question marking scheme. Okay, 0 0.25 ampere. Okay. He says the student opens the switch. Okay, the student opens the switch, and then what happens? The resistance of a resistor can be found using the equation resistance is equals to the voltage across the resistor and the current in the resistor. Because they are connected in series, so all of them, they have the same amount of the current. So the resistor X will be equals to the voltage across the resistor X and the current in the resistor, because they are connected in series. So they all of them have the same amount of the current. So it will be 0 0.5, 0 0.7, sorry, divided by the 0 0.25, and that will be 2.8. So the resistor will be 2.8 ohm. Let's check. 2.8 ohm. The resistor is 2.8 ohm. Okay. Then their question is, so that's why the switch is opened after the reading of the potential difference and the current are recorded. You see, whenever we are doing these current experiments, the experiments related with the resistance, current, and voltage, we close the switch, we note down the readings, and immediately we close the switch. We open the switch, I mean. The reason is because you see, when the current continues to flow in the circuit, because due to the flow of the current, the temperature starts increasing, and when the temperature increases, the resistance of those resistors, the leading wires also changes. So that's why we do not keep the switch closed. We just simply open it immediately to prevent the overheating of the resistors. Okay. So to prevent overheating resistors or cell running down, yes. So this is the reason. Okay, then we have question number 2 is fourth part. He says the student disconnects the voltmeter and reconnects it across the resistor Y. The potential difference Vy across the Y is given by the equation. Vy is equals to 3, which is the voltage of the EMF, which is the voltage of the battery, minus the voltage drop across the X. We have just calculated what is the voltage drop around the resistor X. Using this equation and your values of the Vx from the A first part, calculate the Vy and calculate the resistance Ry of the resistor Y. Okay, so very simple. We know the voltage drop. So the voltage across the Y will be equals to 3 minus 0.7. So that will be 2.3 volt. And because the X and Y, they both are connected in series, so they have the same amount of the current flowing through them. So the resistance of the Y will be equals to the voltage across the Y divided by the current flowing through the Y. So that's 2.3 volt divided by 0.25 ampere. And the answer will be 9.2 ohm. The answer will be 9.2 ohm. The voltage across the Y will be 2.3 volt and the resistance will be 9.2 volt. Let's check. Okay. 9.2 volt and 2.3 volts. I hope you understand this. It's a very simple, straightforward question. Okay. So here we have question number 2. It's a B part, it's first portion. The student now connects X and Y in parallel. Before they have connected them in series, so there was only one path for the current. Now they want the X and Y resistors to be connected in parallel with each other. Complete the circuit diagram in the figure 2.3 to show the two resistors connected in parallel between the point W and Z. Draw the voltmeter connected to measure the potential difference of Vp across both the resistors. So this is basically a 2 marks question, and let's see, I have done this. So here we go. So here you can see we have connected the resistor X and the resistor Y. They are parallel to each other between the W and Z. And here we have connected a voltmeter, the voltmeter in such a way that it will be able to calculate the potential difference between potential drop across the both the parallel resistors, or you can say potential difference across the W and the Z. And the ammeter will be telling you how much is the current flowing through the, okay. So this is how this is drawn, and now we have this. Theory suggests that if two resistors are arranged in parallel, the combined resistance RT is given by this formula. Use the equation and your values of the Rx and Ry from the A second part and the A fourth part to calculate the RT. We all already know the Rx value, the resistance of the resistor X, and we already know the resistance of the resistor Y. And you will simply put those values here in this formula and do your calculation carefully with the help of your calculator. We have done that. So here we go. So here we have, okay. So 2.8 into 9.2 and divided by, in the denominator, we will have 2.8 plus 9.2. This is the value of the Rx and this is the value of the Ry. So you will get 2.146, which is approximately 2.1 ohm. 2.1 ohm, 2.1 ohm, and our answers are right. So then we have, this is the third part, question number 2B, and its third part. The manufacturer suggests that the combined resistance of resistors X and Y when placed in parallel is 2.5 ohm. Two quantities can be considered to be equal within the limit of experimental accuracy if their values are within 10% of each other. State whether your value of the RT calculated in the B second part has the same value as that suggested by the manufacturer. Support your statement with our calculation. So they say that the true value should be 2.5, and but our value is 2.1. So we will check how much is the difference between the true value and the value which we have just found. And we will check how much is the difference, okay? So the difference is, they say the value will be 2.5. We say the value is 2.1. So the difference is of 0.4. So 0.54, which is the difference between the practical value and our original value. and multiply 100. So that is 16%. So that difference, so this, they said that if the difference is 10%, and then they agree with each other. They are within the limit of experimental accuracy, but our difference is 16%. So we will say no because they are not close enough. The difference, our difference is 16%. So up to 10% difference is acceptable. Up to 16% difference is not acceptable. So the readings are not close enough. They do not agree with each other. Okay, so we have to show this calculation. The calculation which we are supposed to show is this calculation. Okay, this way. I hope you understand this. And so we are going to the next question. The next question is question number 3 coming up on your screen. A student does an experiment to find the mass of a meter rule. A fixed mass is placed on the meter rule at 5 centimeter mark as shown in the figure 3.1. So this is a meter rule which is approximately 100 centimeter long. And from this zero end, it's 5 centimeter here, we place the mass. And at 25 centimeter mark, we have a pivot. So between this point and this point, the moment arm will be like 20 centimeter. And at 50 centimeter, the weight of the meter rule will be acting. So its distance from the pivot, the center of gravity, will be at 50 centimeters. That will be 25 centimeter. He says that the student places the pivot below the 25 centimeter mark on the meter rule. Places a mass of 20 gram on the meter rule, adjusts the position of the 20-gram mass until the rule is as close to balance as possible. The position of the 20-gram mass when the rule is as close to balance as possible, as shown in the figure 3.2. So using the figure 3.2, determine the distance d of the center of the 20-gram mass from the pivot. So method is very simple. You check what is this reading. So let's say approximately this is 21.1 and this reading is 22 point maybe 8 or 22 point, sorry, I'm saying 22. This is 81.1, I think. And this reading is 80. This reading is 82.9 or 82.8. So we will subtract them, or you can add them up and divide with the 2. You get the point. Okay, so 82.9 minus 81.1, and whatever is the difference between two readings, then you divide with that thing with the 2. So whatever is the reading, that is 0.9. Then you add this in 81.1 and you will get the reading 82. Okay. So the center of that mass is at exactly 82. Now the question is when the meter is close to the balance as possible. So we have to tell how much is its distance from the pivot, because the pivot is at a mark of 25 centimeter and the mass 20 gram is placed, its center of gravity is placed at 82. So that the moment arm or the distance between the pivot and that point is 82 point minus 25, that is 57 centimeter. So the moment arm or the distance between the pivot is, yeah, they say 57, our answer is also 57. I hope you understand. Okay. Then we have, they say using the figure to determine the distance d of the center of the 20-gram mass from the pivot. We are done with this. Describe the relationship, describe the technique the student uses to balance the meter rule with the 20-gram mass. So the 20-gram mass, you will move it forward, backward, forward, backward. So you will move it forward towards the pivot, and obviously and you will check at what point the meter rule comes in balance. So when you're moving the meter rule, let's say tilt to the left, then move it backward, then it will tilt to the right, then again do this, and then find very carefully moving that mass which is placed at 82 centimeter, moving it left or right very carefully. You are going to find that point where the meter rule will be balanced on that pivot. So it's kind of hit and trial. You move it forward, you move it backward, the mass of 20 gram on that meter rule. You move it a little forward, you move it a little backward, and you try to find out a point where the meter rule will be balanced. Okay, so let's see, move the mass backward and forward until the meter rule is balanced. So this is our answer. Let's check the marking scheme. What the move the 20 gram mass backward and forward or slowly along the rule until the balance is achieved. Okay, so I hope you understand. Then we have the student repeats the procedure for the values of the mass 30 gram, 40 gram, 50 gram, and 60 gram. The table 3.1 shows the results. So add your value of the D for the mass 20 gram in the figure in the A first part in the to the table 3.1. So that was something 57, I think. So we will add that value here, 57, and then we will have to calculate the 1 by D for each mass M and record all the values. So this value is 57, then I will, here you will have to reciprocate the D values. So like 1 divided by 37, I write here, 1 divided by 28, I will write here, 1 divided by 22, I will write here, 1 divided by 18, I will write that thing here. Okay, so let me show you. So when I will divide 1 by 57, that will be 0.018. When I divide 1 by 37, I get 0.027. 1 divided by 28, I get 0.036. And 1 divided by 22, and that will be 0.045. And 1 divided by 18, that will be 0.056. He says, suggest why a value of D cannot be found for the mass equals to 10 gram. You see, the lower the mass you are putting on the right side, the larger is distance from the pivot. This meter is like a 100 centimeter long, and the pivot is as 25. And so you only have 75 centimeter of the meter rule on the right side. So if you will make the mass less than 10 grams, so the distance you have to achieve the balance, the distance you have to move the mass away from the pivot, that will become more than 75 centimeter, and you will be not on the meter rule anymore. You will be off from the meter rule. I hope you understand what I'm saying. D would be too big to be measured on a meter rule. Then the place which we have on the meter rule is only 75 centimeter from the pivot. Huh? So that is the answer, I think. And let's read. D becomes greater than 75 centimeter of the end of the rule. No balance point ruler, not long enough. So this is our answer. I hope you understand. He says, using the grid provided in the figure 3.3 on the page 13, plot a graph of 1D on the y-axis. So the value of the 1 by D we have to take on the y-axis against the mass on the x-axis. Start your axis from the origin, 0, 0. Draw the straight line of the best fit. This is a 4 marks question. So let me show you. I can show you the graph here. They have shown. Let me reduce the size so you can see the whole thing. So this is the figure 3.3. The graph is given. So on the y-axis, we have to take the value of the 1 by D. On the x-axis, we have to take the value of the mass. The masses are going from 20, 30, 40, 60, 50, and 60. And the 1 by D values are going from 0.018 to 0.056. Let me show you. So here on the x-axis, we are going to represent the mass. So 2 centimeters are representing. So this is 10 grams, 2 centimeters, 20 grams, after 2 centimeters, 30, 40, 50, and 60 grams. On this y-axis, we have represented 4 centimeter with 0.01, and next 4 0.02, and next 4 centimeter 0.03, and next 4 0.04, and the next 4 0.05. Okay, so the table which we are going to use is this one, and this says at at 20, you will put a dot of 0.018. At 30, you will put a dot of 0.027. At 40 on the x-axis, you will take the y value as 0.036. And at 50, you will take the value as 0.045. And at 60, you will take the value 0.056. So we are going to plot those values here. So let me just reduce the size so you can see the whole thing. So at 20, you put this dot, at 30, you put this dot, at 40, you put this dot, at 50, you put this dot, and at 60, you have put this dot. Then you will join them with the help of a scale. You will draw the line of the best fit. The line of the best fit is always drawn in such a way that we make sure that all the points which you have plotted them, the line is in the same pattern and the line cuts the maximum points, and the number of the points which are left above that line is equal to the number of the points left below the line. So this is the line of the best fit. On this x-axis, we have represented the mass, which is measured in grams. On this y-axis, we have represented 1 by D, whose unit is 1 by centimeter. So this is very, very important. The labeling is very important. It carries 1 mark for this. So you can read the marking scheme here. Okay, then this is that graph paper. Then their question is, then the question they are asking is, after plotting, this is a 4 marks question. They say calculate the gradient G of your lines, show all your working and indicate on the graph the values you use. It's a 2 marks question. So I'm going to take this point on the line of the best fit, and I'm going to use this point on the line of the best fit. And what I will note down the coordinates of these 2 points. So this point is something like 33, comma 0.03, and this point is 56, comma 0.0515. Then I will join them with these dotted lines and I will make a triangle. So I will measure how much is this thing. I will calculate how much is this and how much is the rise, how much is the run. And with the help of here you see, so we will calculate the gradient. This is how. So y2 minus y1 divided by the x2 minus x1. y2 minus y1 divided by x2 minus x1. So they say the reading will be 9.6 expo minus 4. A little bit up and down is possible. Our reading is approximately in that answer, in the range of that answer. Okay. So you can also try your values and it will be a better answer. Our answer is little off, but there's no problem. The technique is this. This paper has been solved. Basically, we solved this paper in our class. I solved this paper with my class, and the solution which I'm showing you, this solution has been written by one of my students. Her name is Hajra Iftikhar, and she's very, very, her IQ is very good, and we are hoping that she will get A stars in the physics. So the solution is not written by me, but the solution has been written under my supervision. So I hope you understand how to find the gradient. Our answer is a little off from the answer given in the marking scheme, but there's no problem in it. You're supposed to learn the technique basically. The mass m of the meter rule can be calculated using this equation. So you see this equation is very simple. It's a straightforward equation. The mass will be equal to 160 minus 0.040 divided by the G value, the G we just calculated. We will put that value here in this formula and we will just calculate, and that will give you the mass of that. Okay, so here we go. You see, so here we got 160 minus, and then we have 0.04 divided by 9.3 x power minus 4. And when we enter these values in our calculator, the reading is 116.98. So when you round it off into two significant figures, it is 120 gram. 120 gram. 120 gram. Let's check the answer, sir. They say the answer can be from 110 gram to 130 gram. Our answer is 120 gram, exactly in the middle of that. Their suggested answer. So hopefully you know this. Then they say, this is the D part of the question number 3. He says, uh, here we have the mass fixed at 5 centimeter. Here we have the pivot. This is a 100 centimeter long rod. Here we have placed the modeling clay. The student is given a piece of modeling clay. He places it on the meter rule as shown in the figure 3.4. He finds that the meter rule is balanced when the modeling clay is a distance of 40 centimeter from the pivot. Using your graph in the figure 3.3, on the graph, find the mass of the piece of the modeling clay and show your working. So if the modeling clay is put here on the 40 centimeter mark, then this distance will be 40 minus 25, and that will be something like 15, I think. And no, he said when the modeling clay is a distance of, okay, so he has given us the distance. Sorry, I thought that this reading 40 centimeters is the mark here. No, it is the distance from the pivot and the clay when the meter rule is balanced is 40 centimeters. So this is the small d value, that is 40 centimeters. So just find the 1 divided by d and then check on the, so 1 divided by 40, that is 0.025. And you will go to your graph, 0.025. So on my graph, on the y-axis, I will check where is the 0.025. So this is that value. From here, I will come to the line of the best fit. And under that, I will check what is the value. So that is 27, I think. So that reading is 27. Let me show you the whole graph so you can understand. So you see, they have given me the D value is 40. So what I did, I just reciprocated 40. And I found that answer to be 0.025. So from the on my graph, on the y-axis, we have 1 by d value. So from there, I check where is the 0.025. From there, I come to the graph. When I intersect the graph, under that point, I check what is the value of the x, and that is the mass of the meter rule. So that is approximately the answer which I gave to you, and that's 27. Okay. So that answer is approximately 27 gram. Okay, so let's check. So we say, he says 28 plus minus 3 grams. So our answer is in that range, 27 gram. Hopefully you understand. Okay, so we are done with the question number 3. Now we are going to the next question, that is question number 4, and this is the question which we call the planning questions. This is a new type of questions which have been added into your paper since 2023. These are the planning questions. You have to plan an experiment. You have to write a plan for an experiment. A student uses ice cubes to investigate the time taken for different masses of ice to melt when the ice cubes are placed in the water. Plan an experiment using ice cubes to investigate how the mass of the ice affects the time taken for the ice to melt. The following apparatus is available. Top pan balance, supply of the ice cubes, 20 centimeter cube beaker, supply of the cold water, and the stopwatch. And you may also use other apparatus and materials that are usually available in a school laboratory. In your plan, you should explain briefly how to do the investigation. State the key variables to keep constant. Draw a table with the column headings to show how to display readings. You are not required to enter any reading in the table. Explain how to use these readings to reach. You do not have to include a diagram of the apparatus you use, but you may do so if it helps your plan. So this is the question, and this question is of how much marks? It is of 6 marks. Okay. So basically, we have ice cubes, and I want to know that how much time it takes for the ice cubes to melt, and I will increase the in each experiment. I'm going to change the mass of the ice cubes which I'm using. So we are going to use identical ice cubes. We are going to put them in a water, which is in a beaker. Let's say we put 2 ice cubes, and we note down how much time it takes for the ice cubes to melt completely. Then in the my next experiment, I will let's say use 4 ice cubes, and I will note down how much the time is taken to melt those 4 ice cubes completely. So you see, uh, so each time when you're working, the ice cubes must be identical. The initial temperature of the ice cube should be same. The water in which you are putting the ice cubes, and with the help of a stopwatch, you are noting down how much is the time taken to melt completely those ice cubes in the water. That water volume should be all the time same. Initial uh, the initial temperature of that water should also be same. So you are going to use a stopwatch. Also, you may use a thermometer to measure the. Okay, let's check what the marking scheme says. Method number 1, he says, measure the mass of the ice cubes, add ice to water. Measure the time taken for the ice to melt. Repeat for different masses a number of the ice cubes and key variables which you may keep constant. Initial temperature of the water should be same. Initial volume of the mass of the water should be same. Size and the mass of the each ice cube should be same. Room temperature should remain same. Amount of the insulation on the beaker, if you are using an insulation around the beaker, that should be same. The table you will draw with the columns of mass of the ice cubes, or you can write the number of the ice cubes and the time taken for those ice cubes to melt. So from conclusion, the marking scheme says that anyone from compare the reading to see if the mass of the ice cube does affect the time taken to melt, or plot a graph of the time against the mass and the number of the ice cubes. So this is what the marking scheme is saying. So you can pause the video and you can check what the marking scheme says. Here I'm going to show you one of the, okay. So here you can see we have drawn a diagram because that makes our description easy. We have taken our electronic balance to know the mass of the, we know the initial mass of the water should be all the time same. And here we have put a thermometer to make sure that the initial temperature of that water is also same. We will place the ice cubes. From there, we will be able to find out the mass of the ice cubes. How? We will have the mass of the beaker and the water and thermometer, everything. And when we'll place the, let me say that is M1, and when I will place the ice cubes in that beaker, which is filled with the water, then the reading on the electronic balance, I will note it down. I will call it M2. From M2, I will subtract the M1 reading, and that will give me the mass of the ice cubes. You can also count the number of the ice cubes. Okay, So we are going to use a stopwatch to note down how much time when we have placed the ice cubes inside, and then we will start the stopwatch and we will note down how much the time is taken for those ice cubes to be completely melted. So in the table, I will have mass of the ice cubes, or you can say number of the ice cubes, and the time taken for the ice cubes to melt, and that will be in minutes. So, and then you can draw a graph. On the x-axis, you will take the mass of the ice cubes, or you can take the number of the ice cubes on the x-axis. And on the y-axis, we will take the time taken for the ice cubes to completely melt. So here we have, this is answer is written by one of my students. Her name is Hajra Iftikhar, and we are thankful to her because she has written that solution. And that solution has been written by under my supervision. But let's read her solution. In the beaker, pour water. Measure initial temperature of the water using thermometer. Measure mass of the beaker and water using the electronic balance. Let it be M1. Add ice cubes and measure new mass. Let me call it M2. To calculate the mass of the ice cubes, do this calculation, M2 minus M1. Immediately start stopwatch and stop it when all the ice has melted. To measure the time taken for the ice to melt, draw a table so as shown. Repeat the experiment, but increase the number of the ice cubes each time. Keep the initial temperature of the water, mass, and the volume of the water, mass, and volume of the ice cube, room temperature. The mass of all the ice cubes must be identical. Okay. Temperature same throughout, the room temperature should be same throughout all experiments. Plot a graph of the mass of the ice cubes on the x-axis and the time taken for the ice to melt on the y-axis to conclude the relationship between them. By looking at the shape of the graph, you will be able to tell that what is the relationship between the time taken to melt the ice cubes and the mass of the ice cubes. So this is the planning question, and that's it. And this is the marking scheme. You can pause the video and you can take your time, read it. You can also read this solution. And with this solution, we have also drawn this diagram, this table, and this graph. And this is that solution. You can pause your video and you can have a look at this. And here's the size. So you can see this. Okay. So we are done with this paper. So this was. So my dear students, we are done with this paper. Today in this video, we have given you the solution of the Cambridge O Levels Physics 5054 alternative paper. The code of the paper is 41 October November 2024. So I have done the solution to the best of my knowledge and to the best of my abilities. And the reason we are doing this paper is to provide support to the students all around the globe who cannot afford, they cannot hire a teacher. So by just looking at the YouTube video, they will be able to solve this paper. So if you find this paper, this video interesting, useful, and you think this can be useful for other people also, please share the link of this video on your WhatsApp groups and on your Facebook, on your TikTok, on your Instagram. Share the link of this video on your X, on your LinkedIn, because when you share this, when you share the link of this video, this supports me. Also like this video, also subscribe my channel. Your support is very, very important for me. And at the last, I want to give the credit to the Cambridge Assessment International Education, CAIE. You know, this paper has been created by the Cambridge Assessment International Education. I have simply downloaded this paper and I am presenting you the solution of this paper. The paper and the marking scheme which we used in this paper, They both are published by the Cambridge Assessment International Education, and the credit goes to them. I have simply written the solution of those papers. So the paper and the marking scheme is the property of the Cambridge Assessment International Education. Thank you very much. Have a good day, and may God bless you all, and may you succeed in your dreams.